Good day and welcome to second quarter. For this quarter, in pre-calculus, our main focus now is on trigonometry. And on this video, we will be discussing our first topic for this second quarter, and that is all about the unit circle. For our objectives, we are first to illustrate the unit circle and the relationship between the linear and angular measures of a central angle in a unit circle. Then convert degree measure to radian measure and vice versa. Illustrate angles in standard position and coterminal angles. And lastly, solve for the arc length of and the area of a sector. And on this video, this will be divided into two parts. In the first part, we will be discussing more about the unit circle and the coterminal angles. Then on the second part, we will be having the solving part that uses the formula. So such as you're converting the degree measure to radian measure and solving for the arc length and the area of a sector. And without further ado, let us start first by defining what is an angle. So an angle is the union of two rays emanating from a common point called the vertex of the angle. And just to rephrase this, our angles are composed of two rays that intersects on their endpoints. And that intersection is what we call their vertex. So for example, these are two intersecting rays, and they are intersecting at their endpoints. No? And this part is what we call your vertex. Next, it is also formed by a rotating ray about its endpoint. So if we're going to rotate a ray, let's say this is a ray, and this is to be rotated, then an angle there is also formed. And lastly, to measure our angles, we use this angle measurements such as your degrees, minutes, seconds, and radians. And the most common way for us to measure our angles are with the use of your degree measures and your radian measures. And later, I will be showing to you what are the counterparts of the degree measures in radian measures. But first, let us proceed. Now, in our figure shown here below, we have two different angles. They are both called your angle AOB, and the initial side of both angle AOB is OA. This side is the initial side. And basing on this term, when we say diba, initial, it's like the start. The same siya here with our initial side of an angle. This is the side of the angle where our angle are starting from. And diba, we have said that an angle is formed when you rotate a ray. So ayun, this is the starting, kumbaga, na point. Next, its terminal side naman niya is side OB, this side. And if we define what is a terminal, diba, literally a terminal means it's movable, right? So ayun, the movable side of the angle is what we call your terminal side. And for this case, we have side OB as our terminal sides. Next, an angle is said to be positive if the ray rotates in a counterclockwise direction, just like this one. This angle rotates in a counterclockwise direction because it is denoted here. Thus, if the ray rotates that way, counterclockwise direction, then your angle there is positive. And the angle is negative if your ray rotates in a clockwise direction. Next, also, it is important for us also to know if our angles are in standard position, because later if we're going to solve for the reference angle, the coterminal angles, our angles must be in standard position so that we can solve for it directly. Okay, so how do we know if our angle is in standard position? So an angle is in standard position if it is drawn in the Cartesian plane with its vertex at the origin. This one, its vertex is at the origin, and its initial side is on the positive x-axis. Ayan. So those are the things that we need to know first in order to consider that our angles are in standard position. Again, its vertex is at the origin and its initial side is on the positive x-axis. Now, since we are dealing with angles, no, there are also ways for us to measure the values for these angles. And one of the most common, or this is actually the most common way for us to measure our angles, no? And it's with the use of our degree measure. So ang palatandaan lang natin for degree measure is that it has a degree symbol. And just for everyone's information, maybe you have forgotten about this, one complete rotation of an angle in degree measure measures 360 degrees. Okay? So yeah. Next, the other way for us to measure our angles measurements is with the use of the radian measure. Now, these two pictures are actually corresponding to each other. Whatever the value here in degrees are, it is also written here in our radian measures. So, ayan. One complete rotation of an angle in radian measure is 2 pi. Ayan. So, those are the things that we need to consider first, or what's really important for us to know first. And to know more about the radian measure, this is actually, or the angle measurements for our radian measure is derived from our unit circle. Now, our unit circle, the graph of the equation below, x squared plus y squared is equal to 1, is a unit circle having its center at the origin and the radius is equal to 1. So this is the graph of our unit circle, and again, this is called your unit circle because its radius, no? Its radius is equal to 1. Yan. And why is this essential, no, for us to know that this is a unit circle? Because the circumference of a circle is given by 2 pi r, right? That's the perimeter of a circle, or the circumference, where r is the measure of the radius. Then, if we are given with the unit circle, the circumference of this unit circle is equal to 2 pi. And if you have recalled during your grade 10 na mathematics, di ba, you have discussed before the central angle. The central angle is the angle whose vertex is at the origin, di ba? So like for example, we'll have this angle, abeo, yan, this one. Now, this is considered to be a central angle because, again, its vertex is at the origin. And whatever the measure of the angle is here, that is also the measure of its arc. Like for example, let's say this is 10 degrees. Then, the measure of this arc is also 10 degrees. Or 10. Ayan. Now, going back with the circumference of the unit circle. Now, if we're going to complete the rotation of a ray, diba, it forms a 360 degrees or 2 pi in radian measure. Diba? Therefore, if you're going to get the measure of the circumference, it must also be equal to 360 and 2 pi. So, ayun. That's why the um, one complete rotation of an angle in radian degree is 2 pi because again it was derived from the unit circle. Thus, the distance 1/2 away from around the unit is pi. So again, start kita dire. One complete rotation is 2 pi. Half of it, or 180, is pi. Next, 1/2, then 1/4 of the way, meaning 1/4 siya sang circle. So that's pi over 2. And ang half again ng pi over 2 or 1/8 of the unit circle is pi over 4. And so on and so forth. So that's how we got the unit circle or the radian um, radian measures. Next, let us proceed with our exercises to further know if you have really understood our discussion for this in this video. So we have already answered this, and just a recap lang, we'll again answer this one. So in the following figure, identify the terminal side of an angle in standard position with given measure. So let's start off first with 135 degrees. So again, we are considering that our angles are in standard position, diba? So dapat the vertex is here and its initial side is at the positive x-axis. Next, in order for us to know if where is 135 degrees, let us consider our quadrantal angles, no? Diba we have 90 degrees, 90 degrees na there siya. Then here is 180 degrees, and this one is 270 degrees. Now, we can say that 135 degrees must be within angles 90 degrees and 180 degrees, diba? So, based on our illustration, this is just the area or the ray that belongs to the second quadrant. Therefore, OC is our terminal side for angle 135. And if you want to calculate, and to check if this is correct, so we are given here with a measure of an angle. What we're going to do na lang is we subtract this from 180. So that's 180 minus 45 degrees. That's equal to 135. Therefore, the terminal side is at OC. So it's letter C. Next, we are given with negative 90 degrees, no? So again, our initial side is at the positive x-axis. Then, we are considering here the direction because the sign on our angle is negative. Therefore, the movement of our ray is going clockwise, meaning papunta siya dito. Now, knowing that this is a quadrantal angle because it's 90, then we'll have side OE as our terminal side for negative 90 degrees. Yan. Next, pi over 4. Okay, pi over 4. So let us consider the angle measurements of our illustration here in radian measure. So let's have, diba we have said earlier that one complete rotation is 2 pi. Next, half of it is pi, correct? Kikindivide na lang siya by 2. Next, half of pi, that's 1/4 of this, it's equal to pi over 2. And half, diba, of pi over 2, if we're going to multiply this by in half, then we'll have pi over 4. Meaning, half of 90 degrees or pi over 2 is pi over 4. Therefore, this side is going to be the terminal side for our angle pi over 4. And that is side OB. That's letter E. And last, we have negative pi over 2. So again, we are considering the sine, no, of our angle, which signifies the direction of the rotation of our ray. Therefore, it must go, um, um, it must move in a clockwise direction. Next, pi over 2's equivalence in degree measure, correct, is, di ba, 90 degrees. Therefore, pi over 2 is also a quadrantal angle. Therefore, diri siya sa dalumgaling ma-start. So, ayun. We'll have this one. This side is our negative pi over 2. And that is letter A, side OE. Next, let us proceed with our coterminal angles. Diba, an angle in trigonometry, we've said this earlier, is a rotation of a ray. Diba? It is formed when a ray is rotated. Therefore, it has no limit. It also has positive and negative directions in measure, correct? And in general, our coterminal angles are those in standard position that have the same terminal side. Depending to where its direction of the ray is moving towards, mapa-counterclockwise na siya or clockwise man na movements, or if it's a positive or negative na mga angles, as long as they started with, or as long as these angles are in standard position and has the same terminal side, therefore we can say that these angles are coterminals. Now, we can also say that two angles are coterminal if and only if their degree measures differ by a multiple of 360, if that's in degree measure. And similarly, two angles are coterminal if and only if their radian measures differ by a multiple of 2 pi. So in other words, the difference between two angles must be a multiple of 360 or 2 pi. Yan. Regardless how many times you added 360 or 2 pi on your angle, then you will be having there your coterminal angles. Like for example, we have these two given angles, 410 degrees and 50 degrees. So we can say that both angles are in standard position because they started here. Ayan ho, it's denoted by this this line. No? So ayan. Now, we can also see that both have the same terminal side on the first quadrant. But how do we know that both of them are coterminal angles? So let's go back to this definition. No, their difference must be a multiple of 360. So let's try to find the difference of these two angles. No, so we'll have 410 minus 50, and this gives us 360 degrees. Therefore, angles 410 degrees and 50 degrees are coterminal angles. Next, if we are asked to find another coterminal angle for our for an angle that measures 410, we can add another 360 so that we can identify if what angle is that. So ayon, we'll just have one complete rotation, diba? That's 360, then this is 410. And if we're going to add another na rotation, we can have another angle, no, with a different measurements. That is coterminal with 410. So in order to find that angle measurement, we can add 410 by 360 so that we can identify kung ano na siya na angle. So we'll have 770 degrees. Yon. So you can either add another 360 so that you can identify another coterminal angle from your given. Or if you want, you can also determine the negative na coterminal angles. How, di ba? So we can do that by subtracting 360 from your given na angle. Let's say we have this 50 degrees, di ba? That's our starting, or that's our given na angle. So we will be finding the negative na angle for this. So the rotation of our angle is going clockwise, no? And this is its terminal side. Yan. So in order for us to identify if what angle is this, we'll just solve 50 minus 360 degrees. And that's equal to negative 310 degrees. So that's how we're going to solve for our coterminal angles. So to check if two angles are coterminal, again, their difference are a multiple of 360 or 2 pi. Then, if you are asked naman yet to find a coterminal angle for a given angle, just like what we did here, you can either add or subtract 360 or 2 pi from your given angle. But it depends, no, because there are other problems that gives conditions, no, in identifying the coterminal angles. Now, to further understand this, let us have some examples, no, illustrative examples. Now, we have here number 1 are the angles 45 degrees and negative 315 degrees coterminal. And this was already presented during our discussion. So some of your classmates answered that these two are coterminal. Yes, they are coterminal because if they subtracted 360 from 45 degrees, let me just rewrite it. Well, or if you're going to subtract 360 degrees from 45 degrees, 60, its answer is equal to negative 315. And that's our second na given na angle. This is also the same if we're going to add 360 from 315. Diba? Using your calculators, the answer here is positive 45. But basing on our definition earlier, we can also identify if these two angles are coterminal if we're going to find for their difference. And that should be a multiple of 360. Let me just draw a line. So we'll have 45 minus negative 315 degrees. Yan. Is equal to, using your calculators, this will be equal to 360. Therefore, yes, these two angles are coterminal because if we're going to find for their difference, then the answer there is a multiple of 360. Next, give the angle between 0 and 360 that is coterminal with negative 380. So in order to find the coterminal angle for this, again, it must be the angle measurement there must be in between 0 and 360. So dapat within that condition lang yung angle measurements natin. So how are we going to do that? And diba, as said earlier, in order for us to get the coterminal angle of a given angle, we can just add or subtract 360 from our given to our given. Rather. Yun. So for this case, we'll be adding 360 because our given is in negative. Kag what the condition said here, the angles must be in between 0 and 360. So we'll have negative 380 plus 360. This gives us negative 20 degrees, di ba? So hindi pa siya satisfied yung condition. So we'll continue adding 360. And this will now give us um, negative 20 plus 360 is 340 degrees. And di ba 340 is greater than 0 but less than 360. Therefore, in finding for the coterminal angle for this type of problem, you just add if negative, no, just like this one, or subtract if positive 360 continuously until you get the number between 0 and 360. And the coterminal angle for negative 380 is 340. And there ends our first part of this video. Please proceed to our next part of this discussion, and that is on the conversion of angle measurements and solving for the arc length and area of a